All right, so in this lesson, we're reviewing for our upcoming quiz over sections 1.6 and 1.7. We'll be working through each kinds of problems on this review, and then you can go and do the remaining problems on your own. So let's start with number 1. So the learning target for number 1 is I can solve the systems of equations with the elimination method. So I'm going to use elimination to solve this system here. So what the goal is, we're trying to eliminate one of the variables. So either x or y, it doesn't matter, you can choose. Usually you should try to choose the one that will be easiest to eliminate. So for this one, I'm going to eliminate the x term first. So I have a 2x and a negative x. So in order for them to eliminate, they need to have the same number in front and then opposite signs. So since this is a positive 2, this x term needs to be a negative 2 in order for that to cancel, because 2 minus 2 is 0, and then that will cancel. So what that tells me is I need to multiply this bottom equation by 2. So I'll distribute the 2 through to the bottom equation. I'm going to rewrite the top one. That one stays the same. So 2 times negative x is negative 2x. 2 times 4y is 8y. And 2 times negative 6 is negative 12. And now notice when I go to add them, 2x plus negative 2x gives me 0x, and x's are eliminated, and that was the whole goal of multiplying by the 2. Now I can just add the remaining terms, so y plus 8y is 9y, and 3 plus negative 12 is negative 9. And then to solve for y, I would just divide both sides by 9 here. So y equals negative 1. So I have my y value. Now I'm going to find my x value by plugging in the y value. You're going to choose one of the original equations. It doesn't matter which one you choose. It'll come out the same. So I'll just use this top one here. And then plug in the negative 1 in for y there. And now get the x by itself to solve for x. So add the 1 and divide by 2. So x equals 4 divided by 2 is 2. And then finally, you'll write your answer as an ordered pair. X comes first in the ordered pair, then y. So 2, negative 1 is your answer. All right, let's look at our next learning target. So you'll do 2. 2 is like 1, so you'll do 2 on your own, and then check your answer with the posted key. I'll post it under the stream in Google Classroom. So look at number 3. Learning target, I can write the matrix for the system. So we're given a system, 2 equations, and we're going to put it into the matrix form. So you start by making your matrix. This dotted line represents the equal sign here. So my first row, rows go across. My first row is this first equation here. So I'm going to put my x term. The coefficient of the x term is 4. Coefficient of the y term is 6. And then this stands for equals. And then it equals negative 2. And then my second row stands for my second equation. So I'm going to use those coefficients, negative 3, negative 5, 13. So that is writing a system in matrix form. Okay, you try number 4 on your own. Let's look at number 5. So number 5 is an application of solving these systems. So we're given a real life situation, and we're going to put this situation into a system of equations so we can solve for unknowns. So it says a group of 28 people attended a family reunion at Abernathy Park. There were 3 times as many children as adults in the group. Set up a system of equations that represents the number of adults and children in the group. Solve the system to find the number of adults and children in the group. So here's my unknown. This is what I'm trying to find. Solve a system to find the number of adults and children. So those are my unknowns. So I'm going to call adults, number of adults A. A equals number of adults. And I'm going to call the number of children C. C equals number of children. So A and C are my variables in this problem. Now a system has multiple equations. This system is going to have 2 equations because there's 2 unknowns. However many unknowns, that's how many equations you need. So I have 1, 2 unknowns. That means I'm going to have 2 equations. So I'm going to find my first equation by highlighting my key terms here. So a group of 28 people. So I have a total of 28 people. So that means if I add the number of adults and the number of children together, it will equal 28. So that's my first equation. Number of adults, A, plus number of children, C, equals the total 28. Now I'm going to keep reading and see if I can find my second equation. There were 3 times as many children as adults in the group. So there's my second equation there. C equals 3A. So for every 1 adult, there's 3 children. So if I have 1 adult, if I fill in 1 here, that means there's 3 children. Or let's say there's 2 adults, 3 times 2, that means there's 6 children. So children is 3 times whatever the adults are. So now I have my 2 equations and now I can solve it. When you are solving systems, you must have it in order. So I have A plus C equals a constant. That means I need A plus C equals a constant. So this 3A needs to go in front of the C in order for it to be in order. The way you get it to the other side, since it's positive, I'm going to subtract it. So now I have negative 3A plus C equals, these canceled out, so 0. And then I'll put this one on top of it. And now they're lined up. A's, C's equals constant. And now I can solve it. So this becomes a problem by solving by elimination here, just like what we did on number 1. So I'm going to say the easiest term to eliminate would be the A's here. So to eliminate the A's, it needs to be the same number in front, but opposite signs. So if this is a negative 3, this A needs to be a positive 3 because 3 minus 3 is 0 and it would cross out. So that means I need to multiply this top equation by 3. So I'll distribute that 3. 3 times A is 3A. 3 times C is 3C. And then 28 times 3 is 84. And then I'll copy this one underneath and add them together. Those cancel out. 4c equals 84. Divide by 4 to get c alone. And the answer is 21. So there's 21 children at this party. Now to find the number of adults, I'm going to plug that in to one of the original equations. It doesn't matter which one. So I'll just use this top one here, right here. A plus C equals 28. And then I'll take my 21 and plug it in for C. So A plus 21 equals 28. Subtract 21 to both sides. So number of adults is 7. So I have 7 adults and 21 children in the group. 7 adults and 21 children. Final answer. And let's make sure that makes sense. So I'm going to just go back and check. I know I have a total of 28. 7 plus 21 is 28, so we're good there. I know that there's 3 times as many children as adults. So if I have 7 adults, that means 7 times 3 is 21 children. So that makes sense as well. So that's a good sign. When you plug it back in and it makes sense, we did it correct. All right, you try number 6. Let's move on to number 7. Write the systems of equations for the matrix. So I can write a system of equations given a matrix. So here's my matrix here. So the first rows go across. The first row is going to be my first equation. So this column here, this first column going down, those are my x values. My second column is my y values. And then lastly, these are my z values, equals, and then your constant there. So this first row is going to be 4x plus 5y minus 7z equals 12. Then I'll go to the next row. 1x, or just x, plus 6y plus 4z. Oh, where did that c come from? Equals negative 4. Then I'll go to my next row. Negative 6x plus 8y plus 3z equals 11. And that's done. So this is my system that represents this matrix.